The future isn't just arriving, it's bursting through the doors, redefining what we thought was possible. Imagine a world where robots don't just assist, but operate with precision beyond human capability. A world where AI isn't just in your phone, but walking amongst us, playing sports, and even creating art. What you're about to hear isn't science fiction, it's today's reality. Get ready, because new autonomous AI robots have just shocked everyone. First up, a feat that would have sounded utterly insane just a few years ago. Researchers at Johns Hopkins have unleashed an AI-powered surgical robot that removed gallbladders on its own, with absolutely zero physical human assistance. And here's the kicker, it nailed it every single time. They began with the widely used Da Vinci Research Kit, but transformed it with a powerful machine learning model, creating what they call the Surgical Robot Transformer Hierarchy, or SRT. Unlike earlier systems that relied on strict instructions or human guidance, the SRT was trained almost like a medical student. It watched hours of real gallbladder surgeries. Just video, learning by observing how experienced surgeons move, react, and adapt mid-operation. The tests weren't on simple tissue. They were on advanced human-like models, with synthetic organs mimicking the look, feel, and structure of real human anatomy. This robot wasn't just mimicking motions, it was fully executing the procedure, start to finish, across 8 separate surgeries. We're talking 17 individual tasks, including identifying tiny ducts and arteries, placing microscopic surgical clips, and cleanly cutting tissue. What's truly wild is its ability to handle unpredictability. If the synthetic tissue looked slightly different from its training data, it adjusted on the fly. And remarkably, it could understand verbal cues from the surgical team, thanks to the same transformer-based AI that powers models like ChatGPT. A nurse saying, "Check the left clip," would be interpreted and acted upon accordingly. Every single surgery was a success, a full 100% completion rate with no errors. While it took a bit longer than a human surgeon, the precision matched years of experience. This is a monumental leap from even 2022, when a similar system needed heavy human guidance and pre-marked tissues. The SRTH operated freely, adjusted in real time, and completed procedures without relying on scripted actions. The lead researchers say this is about trust. A surgical robot that doesn't just repeat tasks, but makes judgment calls. They believe with more training, it could handle a range of surgeries, eventually operating on real patients with minimal supervision. After this, that doesn't feel like a stretch anymore. Now, let's leave the operating theater and sprint over to a football pitch in Beijing's Yizhuang zone. Here, 4 squads of Booster Robotics humanoids just played China's first ever tournament without any joystick jockeys in the back room. Each side fielded 3 active bots and a substitute, running 2 10-minute halves. These machines could spot a ball from 20 meters out with better than 90% accuracy, track teammates, read the field lines, and decide when to pass or blast a shot. Tsinghua University's lineup edged out China Agricultural University's Mountain C Group 5-3 in the final. Collisions were allowed, so long as no one programmed dirty tackles. Organizers likened the skill level to kindergarteners, awkward gait and all. Yet, the point isn't finesse, it's pure autonomy. Founder Cheng Hao already talks about mixed human-robot matches, stressing total safety first. Given the rapid evolution of underlying vision and control algorithms, that crossover game suddenly sounds less like science fiction and more like an entry on next year's calendar. While we're on big milestones, Amazon just rolled its 1 millionth production robot onto the floor of a fulfillment center in Japan. Robots now sit nearly 1-to-1 with human employees across more than 300 global facilities. And the entire fleet has a new conductor, DeepFleet, a generative AI foundation model that coordinates every little shuttle's path, anticipating traffic and reshuffling tasks on the fly. DeepFleet cuts travel time by a solid 10%, meaning packages should reach the conveyor belt and your doorstep faster and with lower cost per trip. Vice President Scott Dresser points out that these machines aren't displacing frontline staff. Instead, they're taking on the unforgiving, heavy lifting jobs while Amazon upskills workers into technical roles. Since 2019, 700,000 people have moved through those training tracks, learning to maintain or program the very bots whirring past them. Speaking of companies betting hard on physical AI, Intel just spun out its RealSense division into a standalone firm, announcing a $50 million Series A investment backed by MediaTek Innovation Fund and Intel Capital. Nerdov Orbach, who previously led Intel's Incubation and Disruptive Innovation Unit, now wears the CEO badge. RealSense retains roughly 130 engineers, and its depth-sensing cameras already live inside drones, factory pickers, and autonomous lawnmowers. Orbach says the fresh cash will unlock new product lines aimed squarely at safety and plug-and-play ease. Intel retains a minority stake, but the message is clear. The timing is now for physical AI, and they want external capital to chase the demand curve before someone else does. Art lovers aren't left out of the disruption either. IDA, the ultra-realistic humanoid with hazel eyes and a straight-cut bob, just unveiled an oil portrait of King Charles called Algorithm King. The robot's arms swap tools depending on the medium. Last year, it painted Alan Turing and fetched more than $1 million at auction. IDA explains every brushstroke in slow, deliberate cadence, claiming the goal isn't to boost the bank account, but to spark debate around responsible innovation. The new piece nods to the monarch's work on environmental conservation and interfaith dialogue. Creator Aidan Miller built IDA in 2019 with Oxford and Birmingham AI researchers, framing the whole project as an ethical arts experiment. The robot doubles down, insisting it's here to widen conversation, not to push human painters off the canvas. Whether collectors accept code-generated artwork as true creative output is, in IDA's own words, an important and interesting point of conversation. Back on the desktop, Hugging Face wants a tiny robot sitting next to your keyboard. Reachy Mini stands 11 inches tall, wiggles antennas, tracks your face, and dances out of the box with 15 pre-programmed behaviors. Yet, its real draw is its openness. For just $299, you get a kit that tethers to your computer. Throw in another $150, and the company bundles a Raspberry Pi 5, a battery, Wi-Fi, 4 microphones, and an accelerometer, letting the bot roam untethered when shipments start late this summer. Every hardware file and software routine goes straight to GitHub. So kids, hobbyists, or anyone who can string together Python can teach Reachy new tricks or download someone else's. Hugging Face even plans JavaScript and Scratch support, hoping to seed a community that shares motion packs the way modders trade game skins. Training robots safely and quickly is still a bottleneck, though, and researchers from the University of Sydney and NVIDIA just proposed a clever workaround called Q-STAC. Traditional reinforcement learning either learns fast and crashes often, or stays safe at turtle speed because it depends on hand-tuned cost maps. Q-STAC fuses model predictive control, the disciplined planner that checks constraints every millisecond, with deep reinforcement learning. But crucially, it swaps out the usual gradient step for Stein variational gradient descent. Think of model predictive control as a GPS route and Stein variational gradient descent as a swarm of particles being nudged toward higher reward paths. The beauty here is that Q values themselves generate the safety-aware cost map on the fly. So, no one has to write custom penalties for every nut and bolt in simulation. Q-STAC hit 80% task performance with just 68.8% of the samples needed by the next best competitor, and it nailed fruit picking in the real world at 93.3% success. That kind of efficiency and built-in safety could spill into warehouse pick and place, autonomous vans weaving through traffic, or any scenario where trial and error is pricey. Of course, none of this matters if general-purpose humanoids fail to step out of the lab. Brett Adcock, founder of Figure AI, just told the Around the Prompt podcast that Holmes will see useful bipedal helpers within single-digit years. Figure's latest update let its Helix robot perform an hour of non-stop logistics work on a conveyor belt, approaching human pace. Adcock credits sturdier actuators and neural networks flexible enough to handle messy environments. Venture capital agrees. Figure has banked $2.34 billion so far, with $1.5 billion landing in February's Series C that valued the company at $2.6 billion. Robotics funding overall hit $6.1 billion in 2024, up 19% year-on-year. With Tesla's Optimus breakdancing on factory floors, Boston. Dynamics Atlas cartwheeling, and Agility Robotics Digit marching through Amazon pilots. Adcock's bold claim is that eventually a sidewalk or an office will host as many humanoid robots as humans. He sees the humanoid form factor as the ultimate deployment vector for artificial general intelligence. Critics like Fei Li wonder if a single silhouette is truly energy efficient across every job. Yet, Adcock counters that hardware reliability has turned the corner, and the real question now is scale, not feasibility. So, what part of this autonomous revolution shocked you the most? Was it the AI surgeon performing flawless operations? The football bots battling it out on the pitch? Or the promise of humanoids becoming a common sight in our daily lives? Let us know your thoughts in the comments below. If you're as fascinated by the future as we are, hit that subscribe button if you haven't already, and give this video a like to support the channel. Thanks for watching, and we'll catch you in the next one.